Alastair, the Technical Director from Shuko Middle East. I think we'll jump straight into it. Alastair, to welcome you up on stage, please.
Thank you very much. So, should have been good morning. We're running a little bit late, and good afternoon. It's an absolute pleasure to be here. Pleasure to be here in person. I think all of us are a little bit tired, probably, of all the webinars, etc. So, doing this in face-to-face like this is a big pleasure for sure. Now, I'll jump straight into it. Now, cherry-picking the right facade system. Now, what do I mean by that? We have a big arsenal, as facade designers, we have a big arsenal of different types of systems. We have unitized systems, we have male-female unitized systems, we have male-female unitized, we've got stick systems, capped, structurally glazed, and semi-unitized, which is actually interesting, something that Lars touched on in the very first presentation, which you will see a bit more in detail as I go through this presentation. Now, there is no magical solution necessarily as to which option is the right one. Some projects are pretty much clear-cut, and it makes complete sense to do it as either unitized or stick or wherever that may be. But there are other projects where it is not so clear-cut. And I want to give a couple of examples in this presentation as to why it's not quite so clear-cut and how we cherry-picked from different facade options to ultimately create the right option. So this is a project in Beirut. It's called Credit Lebanese Headquarters. And this is split up primarily into two facade types. The upper facade type, FS2, and the lower part, FS1. Now, FS1 is particularly different because behind FS1 is basically a void, whereas FS2 is essentially the curtain wall of the system. Now, FS2 wasn't particularly rocket science. We did this as a fairly typical male-female unitized system. One thing, however, you will notice is the grooves within these mullion connections here, because they wanted to have the insert top-hung windows, but they didn't want the classical insert top-hung windows where you see that additional frame. So we had to design this to specifically insert the window within the profiles themselves. So the face width of the mullions is always the same, whether it's fixed or with the top-hung window. But again, we didn't reinvent the wheel here. We took one of our window systems, but we just modified it to be accommodated within the system. The stack joint, fairly typical, but again, certainly the below phases of the unitized, it was inclining in quite a lot, so we had to make sure we designed that stack joint to always be able to drain the water. Now, whereas if we look more at FS1, this was more complex, and you can even see from the building here how it has this kind of undulating geometry on it, which was ultimately done with, well, this has been touched on before, with cold bending. Now, I don't want to go into the aspects of cold bending, but initially when we looked at this, we thought about doing it as a stick system. It made sense. There was a sub-steel structure here. Doing it as a stick system was somewhat logical. But there are many inherent problems of doing that with a stick system. Certain points here, there's a high risk, especially when you start to manipulate the panels as part of the cold bending, there's that risk of these joints opening up. There's also the risk of the toggle system here not being structurally sound when you have that constant load from the glass wanting to resist against the toggles. Also, there's not the same level of structural bonding here, so that in itself could also be a problem with the cold bending. Also, the bracketing detail here, whilst it's quite nice, we've concealed all the ball fixings there with some nice cover caps, etc. But at the same time, it's not going to suffice for that level of cold bending. And same thing here. This T-cleat connection, when you start to do that cold bending, this will undoubtedly open. So a stick system in this regard, it quite evidently wasn't making sense. So we go back and we look at what we have in terms of our unitized systems, because certainly a structurally bonded unitized system is by far and away the best way to look at this as a unitized system, and with cold bending. So forget all the reading here, but particularly this part, where the back area of the female-female, and again, not necessarily the male-female, but the female-female, is that these back chambers here in the unitized are dry areas. So considering that this facade we had to minimize as much as possible to incorporate it within the steel, so we looked at how can we modify a typical, let's say, female system into FS2. And we did it quite simply like this. And again, we made this nice and simple. We essentially only had two bespoke profiles on this, which is the mullion and the transom, which is the same profile because it's with a mitre joint, and then the clip-on cover cap to conceal the fixings. And this worked very well, kept it simple, and ultimately it was effective on the project. So you can see here on the right-hand side, this is a view from inside of the elevation. So you can see that whole co-bending effect which is happening within the facade, but you can also see how the unitized system was able to accommodate that. So again, we didn't reinvent anything, but it was about cherry picking and selecting that right facade system for the application that was required. Now, Katara towers, which I'm sure many of you are familiar with. I'm sure you've seen it on many different videos, marketing. This is going to be a key feature in the upcoming World Cup in Doha. Now, this project itself is not, the vast majority of this project is not particularly complicated. We have a lot of typical male-female unitized panels on here, but what was complicated and what is complicated are these sword facades. And we say the sword facade because this is the emblem of Qatar. So these elements here. And there were some real key problems or let's say challenges with this facade which we had to overcome. Firstly, they had to be in a unitized facade. There was no access from the outside because as part of the final negotiations, our partner basically gave a cost saving to avoid the need for external access. So these aspects started to increase the challenge, let's say. And at the same time, there's also co-bending in there. So just to make things a little bit more exciting. So, okay, we had to think to ourselves, and the pretext from the customers, they wanted it to be, and obviously price is king, so we need something which is cheap and cheerful. So initially they wanted a male-female unitized system, which invariably is probably the most cost-effective type of unitized facade. However, in this type of geometry, a male-female system is simply not going to work. So we look back at the type of experience that we have and how we can cherry pick different ideas from different projects. This is a project actually in Bulgaria called Vertigo Tower, and this was done with a semi-unitized system. And the benefit of this type of system is its simplicity but ability to accommodate the different geometry. So you have this typical this mullion profile with the nose, which is then installed onto the facade, and then the semi-unitized panels are fixed to that. The different geometry is then accommodated with the same profiles, but just manipulated by the bracketry. So if you look at some of the pictures of the actual installation, so you can see the mullions are pre-installed. The panels are all 2D panels, so there is not the complexity of having to think about 3D panels, fabrication, design, and you can see it accommodates really well the different geometry. However, one aspect here, which is a problem, is the fact that you do need external access. So whilst this was helping and ticking boxes, at the same time it still needed some addressing. So we go back to this this system design here, and we thought, okay, how can we adopt part of this as the semi-unitized part of it, and at the same time be able to give a system which will allow this to function as a unitized system, which will avoid the need for access from the outside. So let's go back to Credit Lebanese. So we've already got experience with the type of female-female system like this. It can accommodate co-bending, so we know it functions. How can we accommodate these two systems into the one system? So we took the external part of this, and ultimately we came up with this. So this is the system design that ultimately was applied on the sword facade here. So we took the semi-unitized mullion concept, and then we took the unitized concept, and we basically joined them together. So we cherry-picked from different projects from our experience and how to join them together to create one solution for something which was ultimately looking very complicated. And we managed to also do this with a relatively low number of special profiles. All of these profiles are custom profiles. There's nothing off the shelf. But this entire facade, this entire sword facade, we were able to do it with only, I think it was about just over a dozen profiles. So in such a complex facade, being able to simplify it in this way was a huge benefit particularly to the customer. And if you look here at this was actually just over a year ago. I think this was one of my last business trips, beginning of 2020. And these were the first panels that were installed on the project. So here we actually have, and these are 3 separate unitized panels. You might look at this and think these are 2 panels with only 1 joint in this running apex, but actually they're not, they're 3 panels. So again, a huge benefit of this is that we were able to do this facade where all the panels were 2D, all the panels were flat, there was no 3D panels, there was no huge complexity for a vast number of dies to accommodate all the different stack joints, all the different inclinations of the facade. So we were able to simplify it significantly while still being able to accommodate the geometry. And if we fast forward to September here, you will see that evidently what we designed, what we created is working. And particularly you'll see this apex, which is a prominent feature of the facade, because there'll be lighting within that aspect there. So all of this geometry was created with a unitized system, or a semi-unitized system here, where we were able to amalgamate different ideas from our different experiences without necessarily reinventing the wheel, but understanding how we can pick from different systems and different experiences and make them work on something which is completely new. And this is those first lonely little panels were installed there. And then here you will see, this is from the beginning of this year, how the project has developed significantly. I mean, we have to also give massive credit to our partner in this project, which was Technical Glass. I mean, their efforts here were exceptional. This would obviously not be possible without a strong partner. But what was particularly satisfying to see is that we created something completely different and completely new. And there's always that question mark, there's always that doubt, is this going to work, is this not going to work? But ultimately when you see images and videos like this, and you see that it is able to work and it is able to function, then this is then hugely satisfying. And I think it will only be literally probably a few months away where this is actually completed. And this you will see, particularly when the World Cup comes up in the next year, this will be one of the flagships in Doha. So thank you very much. I would like now to pass on to our new friends from Libard, Mr. Chem, who's the managing partner and founder of Libard, and he will just give you an introduction to Libard and the type of collaborations that we're working on together. Thank you.